Hello class, this is the second video recording to talk about Markov model. A Markov model is a very useful statistical tool whenever you have to have some sort of transition. For example, if you are given a sequence of DNA amino acids, GATC, you want to know which part of the DNA is gene, which part isn't, you can use Markov model. And also it is very popular when you try to process natural language. So if you are interested more in this model, you can take some machine learning class like CSE 198. But for our 8B class, what we will do is instead of studying the model itself, we'll try to use it. Okay. And the idea of Markov model, in fact, is quite straightforward. In general, Markov model is to use history to predict future. That's basically what it is. Okay. So how does this work? If you look at this figure in here, Markov model has states, and what each state really means is kind of the status of the system. For example, if you look at state A, if right now the system is in state A, the chance for it to go to state E, if you look at it, is about 40%. The chance for it to stay inside A without changing to another state is 60%. So what this really means is the chance for A to go to either A or E is always 100%, right? Because the probability is 100%. Similarly for E, the chance that for E to go to A is 70%. The chance for E to go to stay as E is 30%. What does this really imply? For example, if I'm just generating letters A and E, for example, if right now this is what I have, and I really want to figure out what is the next letter. Well, right now, if you look at our model says, well, right now you're in state A. The chance for you to go to A is 60%, the chance for you to go to E is 40%. So you basically generate a random value between 0 and 1. If that value is less than 0.6, you stay in A. If that value is not less than 0.6, you go to E. So there is some sort of chance involved for the next state, right? And you just repeat this process. For example, I may end up with A just due to chance. And then the next thing, I may end up with E because it is possible that I go from A to E, although the probability is slightly smaller. The idea of the state might be a bit too abstract. Let's look at a single example. So in our PA7 that we will release later on, what we do is we are given some sort of text. The text can be long. And then we will, basically this text is our history. We want to kind of use this history to generate new text, and there is some sort of chance involved. For Markov models, there are different levels. So level 0, level 1, level 2. Basically, the number, this integer value for level indicate how much of history you want to look at to make a decision of what to do next. Level 0 means I don't use any history. So if this is the training text that you have in here, if you build a level 0 Markov model, you know that this occurred twice, green occurred twice, cheese occurred twice, and twice, ham twice, is 2, yucky, 1, yummy, 1. So these are the different states, and there is no transition probability because the current state doesn't depend on any history. So you will start to generate a random word as you go. So the first word I may generate is called maybe yucky, and the chance for each word is basically their frequency. So how many total occurrences, what, 2, 4, 6, 8, 10, 12, 14. So the chance for you to generate Yaki is 1 out of 14. The chance for you to generate this is 2 out of 14. The chance for you to generate green is 2 out of 14, and etc. So you use a random number generator. The first value you generate may be Yaki. And then you generate a random value again, and based on the probability, you may have a this. And then the next one maybe is, and go on. As you can see, it's just each word is totally independent from each other. This is level 0. Okay. So as you can imagine, the sentence you generate probably doesn't make any sense, right? Because you didn't use any pattern that is inherent in the training text. This is a typo. We can also use level 1 Markov model. For level 1 Markov model means the word you generate depends on just one word in front of it. So the model that you will build is, we know that this occurred twice, and then green, cheese, and so again you have these probability, and ham, so these are the states, is, and then you have Yaki, then you have yummy, right? So if you look at level 1 Markov model, for this, this is a state will transition into the next state, which is green. The probability, as you can imagine, is 100%, because if you look at training data, the next word after this, it is always green, right? Similarly, this is a 100% training, 100%, and then 100%, and then from here 100%. But now from is 100%, from is to Yaki and yummy, it is no longer 100%. Each of them has a 50% chance. Okay. So for level 1 Markov model, you generate the first word again randomly. For example, green. And the chance that green is generated, it is basically 2 out of 14, right? And now, what is the next word after green? You have to look at the state. The next state coming out of green will always be cheese, because the chance is 100%. And from cheese, you'll have and. From and, you'll have ham. From ham, you'll have is, because the transition probability is always 100%. And the next thing is, after is, there is a 50% chance you get Yaki, 50% chance you get yummy, and then through the random process, you may get a Yaki, you may get a yummy. If this is what you want to generate, you are done. As you can see, level 1 model is much better than level 0 model. And in our assignment, you can have any kind of level. As you can see, the higher the degree or level is, the closer this randomly generated text will be similar to the original training text. Okay. In our discussion next week, our TA will talk about the details of implementing this idea in Java using hash maps. Okay. So that's our second video for Markov model. I'll see you on Monday.